Given the surface area of the figure shown, which is a cuboid, is 294 units, I would say. We need to find the maximum possible value of its volume. Now, what easy way to do this is to just assume the cuboid is a cube, since a cube can be a cuboid, and since a cube has 6 faces of the same area, we just take 294 divided by 6, which will then becomes 49 units. And to just find the single length of one face, we will just take 49 and square root it, which will then become 7 units. And in order to find the volume of the cube, since we assume that it is a cube, we'll just cube it using 7 cube, which will then become 343 units. And there's the answer for question 1. Now for question 2, line CD, which is line not here, it is perpendicular to line AC. And now perpendicular means that the two lines meet together at 90 degrees. And also that the line DC also meets the line negative 2x plus 7y equals 42, which is not like printed here at D, which is also not here. So now we have to find the coordinates of D. Now firstly, you need to find the line equation of the line AC, which will first be you use y equals mx plus c. So you can use the point of A to replace the x and y, which become 2 equals to m times 0 plus c. Since this is 0, this m plus 0 is obviously 0. So 2 equals to the y-intercept of the line equation of AC. So now that we know the y-intercept, we can just find the gradient quite easily using the point C. Since in this we can really find the gradient. So negative 2 equals to m8 plus 2. So negative 2 minus 2 equals to 8m. If you count negative 4 equals 8m, and finally negative 4 over 8 equals m, which is negative 1 over 2 equals to m. So now we have found the line equation of the line AC, which is y equal to negative 1 over 2 plus 2. Now that we have found the line equation of the line AC, we need to find the line equation of the line CD, which we can find by using the formula rule that wherever two lines meet together perpendicularly, uh, the two gradients multiplied by each other must equal to negative 1. So since the gradient of line AC is negative 1 over 2, we can multiply it by, let's say, y, which is the gradient of the line CD, is equal to negative 1. So we can find y by using y equals to negative 1 divided by negative 1 over 2, which is negative 1 times 2 over negative 1, which we can remove the 2 and negative 1, it should be equal to 2. So the gradient of the line CD is equal to 2. So now we can just find the line equation of the line CD pretty easily, as we have, and since CD is connected to C, where the coordinates of C, so it'll be quite easy. Negative 2 equals to 2 multiplied by 8, the x, and plus C, the y-intercept. So negative 2 equals to 16 plus C. So negative 2 minus 16 equals C. So negative 18 equals to C, which means the line equation of the line BCD is y equals to 2x minus 18. Now that we have found the line equation of the line CD, we can easily find the coordinates of D by knowing that wherever two lines intersect with each other, which is this line right here, negative 2x plus 7y equals 42, intersects with y equals 2x minus 18, which is also line DCD. We can easily find the coordinates by replacing the y with each other. But first, before that, we must find the the proper formula for the entity 2x plus 7y equals 42, which we must find, we make y the subject of the formula, which will become, what, right, first, 7y equals to 42 plus 2x, which will become y equals to 42 plus 2x divided by 7. So this is the formula, line equation of the line equation of the line, this line over here. So now we can just replace the two y's together to find the x coordinate of the point of intersection of the two lines, which is the coordinates x coordinate of D. So 2x minus 18 equals to 42 plus 2x divided by 7. So we can cross multiply very quick. This will become 14x minus 126 equals to 42 plus 2x. So now we can just move the x together, become 14x minus 2x equals to 42 plus 126, which will become 12x equals to 168. So x will be divided by 12 and become 14. So now that we have found that the line, the x equals to 14, this means that the coordinates for D is, uh, x coordinate for D is 14. And to find y, it will be pretty simple. Just replace one of the formulas from which you choose y equals 2x minus 18, 6 is total. The x with 14 is become y equals to 2 times 14 minus 18. So 28 minus 14, 18, sorry, equals to 10, which means the y coordinates of D is 10. And with that, we have found the answer for question 2a. Now, for question 2b, it tells us to find the area of the quadrilateral ABCD, which is A, B, C, and D is not here. So, firstly, we need to find the triangle of ABC since it's already in the map, so it's easier graphing it. So, firstly, you take to find the height of this triangle right here. You will just take the 2 here minus the 2 here, since they are both, they have the same y, which is same x, sorry, which is 0. So it means they're vertical. So 2 minus 2 will become 2 plus 2 equals 4. So here until here is 4 units. And for this one, since they both have the same y units, y coordinates, which mean the horizontally is a horizontal line, so it will just be x minus 0 equals to 8. 8 minus 0. So just take 4 times 8 divided by 2 to find the area of this triangle ABC, the angle ABC. It comes to be 2 divided by 2, which is 16 units squared. Right here, units squared. And with that, we found the answer, the area for that triangle ABC. Now here comes the hard part. You need to find the area of the triangle AC and D. Now this is quite easy since we know that CD and AC is perpendicular, which means from here C until D is 90 degrees, which means that we just multiply AC and AD and CD and divided by 2, we'll just get the answer for area of AC ACD triangle ACD. Let me write quick real quick. So we'll find the length of the width and height of this triangle ACD. We need to use the formula the square root of bracket x, the second x coordinate minus the first x coordinate squared plus second y coordinate minus first y coordinate squared. So we can use it to first find the line CD, which is, as for earlier, it will become the second coordinate, let's say, will be the D. So it will be 14 minus the first coordinate, which is 8 right here. So 8 AC squared plus the second coordinate, which is the coordinate of D, should be 10 minus this here is -2, so it means +2 squared. And this will then become the square root of 6 squared plus 12 squared, which will then become to 36 square root of 26 plus 144. And finally, it becomes the square root of 180. Now, since the square root of 180 is actually a non-recurring decimal, so I'll just write it as the square root of 180. Now that we have found the length of the line CD, we just need to find the length of the line AC, which will be the square root of the second x, which I'll write as e as 8 minus the first x, which is 0 squared plus the second y, which will be -2 minus the first y, which is 2 squared. So it become the square root of 8 squared plus 24 squared. It becomes the square root of 64 plus 16. So then becomes the square root of 80. Now same with the square root of 180 is also a non-recurring decimal, so I'll just write it as negative square root of 80. So now we have found the lengths of AC and CD. So we will just take the square root of 180 multiplied by the square root of 80 divided by 2 to find the area of the triangle ACD. Now luckily these two multiplied by the third, we'll see it becomes 120 divided by 2. So it just becomes 60. But this is not yet done since we had just found the area of the triangle ACD. And we need to find the area of the quadrilateral ABCD. So we will now need to add together the two units, the two triangles, which will then become 60 units square. I'm going to take a simplified form plus 16 units square, which will become 76 units square. And properly 76 units square. And with that, we found the answer for question 2B.